All right, please let's look up. Classification of amino acids based on metabolic fate. Based on metabolic fate. Now, based on metabolic fate, when they say metabolic fate, as you take them in, those amino acids, how are they metabolized? What is their end product? Now, based on metabolic fate, amino acids are classified into ketogenic amino acids, glucogenic amino acids, and both ketogenic and glucogenic amino acids. You understand what it means now? Listen up. Ketogenic amino acids, in fact, this word genic is from Genesis, right? Genesis means what? No, apart from beginning, now Genesis means what again? Start. Apart from to start, to generate, to produce, right? Is it not? Genesis means production. Now, ketogenesis, production of ketone bodies, right? Now, ketogenic amino acids are those amino acids that can be converted to ketone bodies. And one thing we should note about ketone bodies is ketone bodies are alternative energy sources. Now, what is the main energy source of your body? Carbohydrate, right? But if carbohydrate is not there, will you die immediately? You will not die, right? Your body will now go to look for an alternative energy source through a process which can be called ketogenesis. Ketogenesis, production of ketone bodies. So there are some amino acids your body will now look at you. You are shivering. There is no carbohydrate to give you energy. You now look at these amino acids standing there, and they say, "What are these amino acids?" The body will now say, "What are these amino acids doing here? Oh yeah, let me convert them to something that can give this girl energy because she is too young to die." So now the body will now convert some of the amino acids to ketone bodies. Ketone bodies generate energy when they are broken down. Examples of ketone bodies, we have beta hydroxybutyrate, and we also have acetoacetate, and we have acetone. But why I didn't add acetone here is because acetone does not generate energy. But beta hydroxybutyrate, when broken down, it generates energy. Acetoacetate, when broken down, generates energy. Now, those amino acids that are converted to acetoacetate and beta hydroxybutyrate, that's ketone bodies, are called what? Ketogenic amino acids, right? Right. So the only two amino acids that can be converted to ketone bodies are leucine and what? Lysine. So to remember that, I always use lely. Leucine and lysine are the only ketogenic amino acids we have. So leucine can be converted to ketone body, lysine can be converted to ketone body, lely. Alright. Now glucogenic amino acids. They are those amino acids that can be converted to what? Glucose, right? And you know, glucose, is it a carbohydrate or protein? Carbohydrate, right? And that's the main energy source. So the body can also alternatively look at amino acids and say, oh, let me convert them to glucose. So that when glucose are broken down, energy will not be released. Please, I want to say something here. I'll beg you to listen up. Listen up. Now, the process whereby all those amino acids that are converted to glucose are called what? Those amino acids that can be converted to glucose are called what? Glucogenic amino acid, right? While those amino acids that can be converted to ketone bodies are called ketogenic amino acids. Now the process whereby amino acids are converted to glucose is called what? Gluconeogenesis. Gluconeogenesis. Yeah, we already know we're talking about glucose, right? Yeah, we're talking about new, right? Genesis means what? Production, right? So gluconeogenesis is the production of glucose from new sources. Listen up, oh. Production of glucose from new sources. Where do we used to get glucose from before? Carbohydrate, right? But now we are getting it from a new source, what? Amino acid. Do you understand? You can get it also from other sources, but amino acid is one. So gluconeogenesis, production of glucose from non-carbohydrate sources. All right, so that's that. Now the amino acids that can be converted to glucose, the glucogenic amino acids, arginine, histidine, glutamine, glycine, valine, aspartic acid, serine, cysteine, methionine, asparagine, proline, alanine. There are also amino acids, the third classes of amino acids. They can be converted to both ketogenic and they can be converted to both ketone bodies and glucose. Those amino acids that can be converted to both ketone bodies and glucose falls under both. They are tryptophan, phenylalanine, thyroxine, isoleucine, and threonine. Then try isolating typing foods. I've used this nonsense for years. If you ask me till tomorrow, this nonsense I will still use to remember both glucogenic and ketogenic. Alright, so then try isolating typing phones. Then is what? Threonine. Try is what? Tryptophan. Is tryptophan there? Tryptophan. Isolating is what? Isoleucine. Typing is what? Thyroxine. Phone is what? Phenylalanine. Then try isolating typing phones. This one is for both glucogenic and ketogenic. Then try isolating typing phones. So if you are asked in exam, if I'm asked in exam to classify the 20 amino acids, remember your exam is theory. If you're asked in exam to classify amino acids based on metabolic fate, me, I used to start from ketogenic, then both. First, you have to know the 20 amino acids. You're going to know them. Relax. You're going to know the 20 amino acids because after this subheading now, okay, after the next subheading, the next thing we are going to do is to write the 20 amino acids and draw them. Are we tired for that? No. All right, so I'll write the ketogenic. Ketogenic is lely, right? Leucine and what? Lysine. Then the both ketogenic and glucogenic, I'll just say then try isolating typing phones. Then please don't write it for them like that in exam. Then threonine, try, tryptophan, isolating, isoleucine, typing, thyroxine, phones, phenylalanine. So you can see the two letters. In fact, this one 3 set will help you to remember that. Then this threonine, try, tryptophan, isolating, isoleucine, typing, thyroxine, phone, phenylalanine. Then any amino acid remaining, I will know if it falls under this.